Good afternoon and welcome to the session number 14 from the playlist of NEET Physics. The topic is how to find the electrical field intensity if the work done is known in moving a charge in the electrical field region. So based on this topic, I have one question, and a very similar question was asked in the CBSE All India Pre-Medical Test in the year 1995. The question is not the same, but this question is almost the same, which was asked in the CBSE All India Pre-Medical Test in the year 1995. So here the question is, the work done in moving a charge of 0.2 coulomb through a distance of 2 meter in the xy plane from the origin is 4 joules. There is an electric field E acting along the x-axis and the y-axis. So the value of E, that is, we have to find the intensity of electric field. Now here we will try to understand it with the help of this diagram. This is the x-axis, this is the y-axis, and an electrical field of intensity E is acting along the x-axis, and there is another electrical field which is acting along the y-axis. This is the origin, and so the work done in moving a charge of 0.2 coulomb through a distance of 2 meter in the xy plane. So this is the xy plane. From the origin is 4 joules. So if this is a positive charge, so a force equal to Q into E will be acting along the x-axis on this charge, and there will be another force acting on the same charge along the y direction, and that will be equal to Q into E. And the direction of the force will be along the x-axis and along the y-axis. Because this is a positive charge, so the direction of the force will be on this charge will be along the direction of the electrical field. So this charge will be experiencing one force along the x-axis, and it will also be experiencing another force along the y-axis. Now the magnitude of both these two forces are equal, so the charge will be moving in this direction as shown by this arrow in such a way that the angle made by the direction with the x-axis will be equal to 45 degree, and this will also be equal to 45 degree. So here the charge is moving from the origin. So the work done in moving a charge of 0.2 coulomb through a distance of 2 meter in the xy plane. So we have the work done in moving the charge from this position to, let us say, this position. This is, let's say, the point P, and OP here is equal to 2 meter. That is equal to 4 joules. So we have to find the value of the electrical field intensity. So here work done, as we all know, is equal to the magnitude of the force in the direction of displacement. Magnitude of force in the direction of displacement. This is very important. This is very important to remember, the force in the direction of displacement. Multiplied by the displacement. So here there is one force acting along the x-axis which is equal to Q into E, and there is another force acting on the charge along the y-axis which is also equal to QE. So the resultant will be equal to, the resultant force which I am writing here is FR. This will be equal to under root of this QE whole square plus QE. Now this is the force along the x-axis which is acting on this charge, and this is the force along acting on this charge along the y-axis. So the resultant will be equal to the resultant force on this charge along this direction as indicated by this arrow. This will be equal to root 2 QE. So this is the resultant force on this charge which is moving in this direction, and this is the direction which is making an angle of 45 degree with the x and the y axis. Why? Because both these two forces are equal in magnitude. So the charge will be moving in such a way that the angle made by the direction of motion will be with the x-axis and the y-axis will be equal to 45 degrees. So the work done, which is equal to 4 joules, this was equal to the force in the direction of displacement, this is equal to root 2 QE. Root 2 Q is given to us as 0.2 coulomb, and E is, we have to find, multiplied by the displacement. Now the displacement is equal to 2 meters. So from here, this is equal to root 2, and this will be equal to 4 into 4 by 10. 0.2 into 2, that is equal to 0.4. So I have written 0.4 as 4 by 10 into E, and this is equal to 4. So from here, this 4 and 4 will get cancelled out. So E is equal to 10 upon root 2 newt, and this can further be written. If I multiply this value in the numerator, in the denominator by root 2, I will be getting as 10 root 2 upon 2. So finally, the value of E will be equal to, the value of E will be equal to 5 root 2 Newton per coulomb. So the correct option here is C. So thank you very much for joining this session. In the next session, I will be coming up with a different type of a question which has been asked in the NEET or the CBSE All India Pre-Medical Test Examination in the previous year, and the chapter will remain the same, that is the electric charges and fields. So till then, have a nice day. Bye.